Hi, everybody. We're going to continue with the discussion we started yesterday on using the elimination method in order to find the solution to this system of equations. And remember from the problems yesterday, we were looking at equations where we didn't have any terms that were either opposites or the same. So we have to do some modifying. We have to adjust these equations in order to come up with a term that we can eliminate. So we're going to pick up at number 4. We did 1 through 3 yesterday. So let's pick up with number 4. My pen, I got to get that pen working here. Come on now. There we go. I was hoping it would be red. Let's see if I can get red here. All right. When I look at number 4, I have 5x here, I have 4x here. For my y terms, I have a 5y here and a 2y here. I'm really locked in on the y terms here because I see a plus here and I see a minus here. And because those are opposite signs, they're already set up nicely for elimination if I can find a common multiple for the 5 and the 2. And what's the least common multiple of 5 and 2? Hopefully you can tell, well, that would be 10. 5 and 2 both go into 10. So in my top equation, if I multiply everything here by 2, I'll get a 10y here. So that's what I'm going to do is I'm going to multiply everything up in this equation by 2. And as long as you do that to all 3 terms, you're not changing the fact that these 2 sides are equal to each other. It'll still be balanced because you're multiplying both sides by the same value. All right, so in the top equation, let's multiply everything by 2. 2 times 5x, distributive property here, we have 10x. 2 times 5y, we get plus 10y. Equals, and then 2 times negative 15, which is negative 30. I am perfectly 100% okay with you using calculators as you do these problems because I don't want you to get tripped up over the concept just because you're struggling with the multiplying. All right, now my second equation, if I want this to be a 10y as well, or in this case minus 10y, I'm going to have to multiply this by 5. So we're going to multiply everything here in this equation by 5. And so here we go, 5 times 4x, the distributive property. 5 times 4x is 20x minus 5 times 2y, that's 10y, equals, and then 5 times negative 6 is negative 30. Look at that, I have negative 30 in both of these. All right, now I can add these together, which will cause the y's to cancel out. I hope you're writing this all down on your worksheet. I'm going to go through 4, 5, and 6 today. We did 1, 2, and 3 yesterday. And so you'll have the first 6 problems on this worksheet done. Your assignment for tomorrow is going to be to finish 7 through 10. Okay? So, all right, here we go. 10x plus 20x is equal to 30x. These cancel out. Plus 10y minus 10y. They're opposites. And this equals negative 30 plus negative 30, which is negative 60. Okay? And then our last step would be just to divide this by 30, and also the same over here. Divide this by 30. And we find out x equals negative 2. All right? So we found our x value, it's negative 2. So now what I need to do is substitute negative 2 in place of the x into one of these original equations. And I'm going to use the top equation, and I'm using it for a reason. I'm using the top equation because it has a plus 5y here. See the minus in the second equation, the minus 2y? That's going to cause you some issues with your signs. It's going to make it much more challenging. So I think using the top equation here is going to be quite a bit easier to find our y value. So 5x, that's 5 times negative 2. Remember, we just found x is negative 2. So 5 times negative 2 plus 5y equals, and then I have the negative 15 here. I apologize, this is a little messy. I'm writing with this stylus on the screen of the computer of my laptop, and it's kind of hard to do that and be neat. All right, 5 times negative 2 is negative 10 plus 5y equals negative 15. We're getting close now. Now, to get this variable term here to be by itself, to isolate this term, I have to get rid of the negative 10 that's being added to it. So we're going to add 10 here. After all, negative 10 plus 10 is 0. It gets rid of it. That means I also add 10 on the right side of the equal sign. Put a line under this whole thing. Woo, those are gone. So 5y is equal to negative 5. Oops. All right, and then I just have one last step here. I'll divide this by 5, and I'll divide this by 5. And 1y equals negative 1. And we have it done. So x is negative 2, y is negative 1. Let's write them in an ordered pair, going x first and then y. We always want to go alphabetically, even if you were using variables other than the x and the y. So I have negative 2, and I have negative 1. I'll put those in parentheses. That's my solution to this system of equations. In both equations, if you put negative 2 in for x and negative 1 in for y and solve, you'll get a true statement. Okay? All right, so let's look at number 5. And you know, as I glance at number 5, I can see number 5 is going to be a little bit easier than number 4 was. And the reason I say that is because when I look at my y terms here, it's going to be easy to get these to be opposites. Because if I take the top equation times 2, this will become minus 10y, which is the opposite of plus 10y, and then my y's will drop out. I don't even have to change the second equation. So let's go ahead and do this here. Let's multiply everything in the top equation by 2. Okay, so here we have that distributive property again. 2 times 4x, that's 8x. Minus 2 times 5y, which is 10y, equals 2 times 23, which is 46. Sometimes people remember to multiply these by 2, but they forget to multiply that last one by 2. So we do have to be careful to multiply all three terms by that 2. And then this second equation here, I'll just rewrite that underneath this one. So I have 3x plus 10y equals 31. See how nice this is? And then these cancel out when I add these together. 8x plus 3x is 11x. And that equals 46 plus 31, which is 77. 6 and 1 is 7. 4 and 3 is 7. And then I just divide by 11 here and here. Those cancel out. We get 1x equals 7. Now that I know what x equals, let's put it into one of our original equations. I know that first equation, the numbers look smaller, and you might be tempted to use that first equation. I would not, though, because there's a minus 5y. I don't like that because you're going to be dealing with a negative number in front of that y. Let's use the bottom equation. It's going to be better because it has that positive value in front of the y. Okay? So I'm just going to bring it on down here where I have more space. And then I'll fill in the 7 in place of the x, substitute it in. So 3 times 7, my 3 looks pretty bad, doesn't it? That's better. So 3 times 7 plus 10y equals 31. All right, 3 times 7 is 21. 21 plus 10y equals 31. Do you think you're going to be able to do this without showing work, people? Not a chance. You must show all of your work. Then I'll subtract 21 here, as well as here. We're almost done. And the reason I'm doing that is because I want this variable term to be isolated. I want it by itself. So 10y equals 10. That's nice. Last step, divide by 10. Here and here. 10 divided by 10 is 1. 1y equals 1. So x is 7, y is 1. I'll write those as an ordered pair. Boom, there it is, 7-1. All right, I'll do one more problem here. I'll do number 6, and then I'm gonna set you loose to work on your own. All right, get myself out of the way here. In number 6, it's kind of similar to number 5 because the y terms are really set up nicely for elimination. The only thing I have to do in the top equation, remember in front of this y, there is actually a 1 here. It's not shown, but that is one y there. Maybe I should show that one, huh? Boop. Come on, you. Boop. There. There's my 1. It looks terrible. Anyway, I can make that 2y if I multiply everything in my top equation by 2. And then that will cancel out with the minus 2y here. So that's what I'm going to do, is I'm going to multiply everything here in this top equation by 2. And so we use the distributive property. 2 times 2x is 4x plus 2 times 1y, which is 2y, equals, and then remember 2 times 8, we got to do that also. That equals 16. All right, the bottom equation is great as written. Let's just rewrite it here. 3x minus 2y equals 5. And now you can see how if I add these together, the y terms will be eliminated because they're opposites, plus 2y minus 2y. So 4x plus 3x, that's 7x. And it equals 16 plus 5, which is 21. And these are very compatible with each other, 7 and 21. We're going to divide by 7. Divide by 7, and we get 1x equals 3. Nice. Now that I know that, I can find y pretty easily. And I would definitely use my top equation, 2x plus y equals 8. See that plus sign in front of the y? That's why I want to use that one. The second one has a minus in front of the 2y there. That's not as nice. Anyway, 2x, that's 2 times 3, plus y equals 8. All right, 2 times 3 is 6. 6 plus y equals 8. You might be a step ahead of me here. You might already know the answer. Last step, we just subtract 6 here and here. Zing, y equals 2. Boom. We have our x, we have our y. So x is 3, y is 2. Let's write that as an ordered pair. Okay? And that's it. 3, 2 is our solution to that system. All right, so for your assignment tonight, you need to finish numbers 7, 8, 9, and 10. Actually, you can do that in class right now. Use your time well, and this will be due for our next class period. Have a nice day.